Okay, the problem we have is related to what I'm going to show you here. We're let a ball roll along this incline. I'm going to actually roll it. And then after it leaves the incline, what's its motion going to look like? Okay, well, that went by pretty quick. And yeah, depending on the time resolution of your video, you might not even been able to see what happened. What happened was the ball went off the edge and then it followed a parabolic path. Now, if I do the same thing off the edge of a high table 1.2 meters high, then if y is the distance above the floor, that thing will go off the edge of the table, off the edge of the ramp, and fall to the floor, and it'll follow a parabolic arc. And by parabolic arc, I just mean a transformed parabola. Okay? Okay, so if y is the distance above the floor, and t is the time in seconds, also x is going to be your horizontal distance from the edge of the track. We'll talk about that in a minute. We're not going to use that just yet. Then we have this equation. And this is actually an accurate equation, a pretty accurate equation. It would really work pretty well. I'd probably be better to use 4.9 than 5, but 5 is a nicer number, and it only differs from 4.9 by what? Okay, 0.1, okay, which is a 2% difference, okay? So we're not going to worry about that 2% difference. We're not doing precise physics here. We're just illustrating a couple of applications of quadratic functions, okay? So here we have it. So a couple of questions. What's y if t equals 0.3? And what is t when y equals 0? Now, I'm going to kind of quickly explain this. It's using a method I use in my classes, but it doesn't apply to all classes. This is just a transformation of the t-squared function. Now, you've been through transformations. You have a reflection around the t-axis because of the negative sign. You have a vertical stretch factor, 5, and then you raise it 1.2 units. And hopefully we understand transformations that well. Just a brief explanation for whatever it's worth. Here I've got a 4x4 square. It doesn't look much like a square because I have a different scale on y than I have on x, okay? So it's still a square because it's 4 units by 4 units, but it's not really a square because y is measured in meters and t is measured in seconds. So that'd be like 4 seconds and that'd be like 4 meters, okay? If I stretch this square out, or rectangle, whatever you want to call it, then if I stretch it out to get y equals 5t squared, if this is y equals t squared graph, the 5t squared graph is going to have to stretch that thing out to where this distance here is 5 times 4. Now that's 20, of course, but I'll just call it 5 times 4 because you can see why it is what it is, because we stretched this thing out to where we have the 5t squared function. Then we do minus 5t squared. We just flip this thing upside down. The origin, the red dot, if you're in my class, stays here. The graph flips upside down. So now we've got an upside down parabola. Okay. And then we raise it up 1.2 units. We add 1.2. So the origin goes from 0, 0 to 1.20. So this point up here at the top is, I said 1.20, it's 0, 1.2. This vertex of the parabola here, and you want to get used to that term because we're going to talk about parabolas. And then that'll be coming up in your class soon. And hopefully we're talking about it before people get to it in the other classes. Okay, so this point is 0, 1.2. Now, can we make an estimate? What is y if t equals 0.3? if we have this graph, here's where x equals 2, here's x equals 0, here's where x equals 1, of course, here's where x equals -1. 0.3 would be maybe about here, so y would be maybe here. Might be a little hard to see. Okay. Then the question is, what is t when y equals 0? Well, y equals 0 on the x-axis, so that's where this graph crosses the x-axis. If this is 1 and this is 0, that looks like it's about 1/2, doesn't it? And that's a small graph, but I just want to make sure we understand what some of this looks like on the graph. So I can draw a little bigger picture of the important part of this graph. Might look something like this. Now it's more like a semicircle than a parabola. So, but if I draw this little part of the curve up here, okay, let me make this part of the curve purple. I'll make this purple. It appears that t equals 1 about here. So here's the line t equals 1. Okay, does that reasonably well represent that little tip above the x-axis? I mean, reasonably. It's not, we're not going to get an accurate result, but we're going to get an idea what our results ought to be. Okay, and if you use 4.9 instead of 5, it still looks about the same. So this is just kind of a schematic, but it's a fairly accurate schematic. Again, this is the point 0, 1.2. And of course, this point out here is the point 1, 0. Make sure we're oriented to the scale of the graph. Okay, so where is t equals 1/2? Well, t equals 1/2 about where my fingers meet. So I'm going to say this is t equals 1/2. So where t equals 0.3? Well, t equals 1/4 here. And of course, that's 0.25. So t equals 0.3, maybe about here. Now it's getting crowded. But here's the line for t equals 0.3. We could estimate y at this point. If this is 1.2 and this is 0, then y equals 0.6 would be about here. So I'm going to say maybe y equals 0.8. So from the graph, looks like y is about 0.8 when t is 0.3. Okay. So and y equals 0. When t approximately equals what? Well, if this is t equals 1/2, what are the coordinates of this point? It looks like the coordinates of that point might be about 0.4. T coordinate might be about 0.4. So this point here is maybe 0.40. Okay. Well, all that's the picture. And the picture of the function allows you to make estimates, and it gives you a visual of what the equations mean. Now, everybody went to the equation. Nobody really drew that graph. It wasn't giving you that much time. It takes a little while to construct the graph and stuff like that, but if you practice it, you get good at it. If you know how to use transformations. Okay. So now, accurate solutions using algebra. I'm going to call this function f of t, just so I can refer to it and make sure we're really used to the f of x and f of t notation. Y equals f of t equals 1.2 minus 5t squared. Y, if t equals 0, y equals f of 0. And since t has been replaced by 0, replace this t by 0. Does that answer an important question? Doesn't answer either of these questions, does it? But it does confirm that if t equals 0, y is 1.2, and that's because of the point 0, 1.2. Why is it 0, 1.2? Because when we transformed the function, we got this. Transformed the t squared, we got the negative 5t squared. It looks like this. And then we added 1.2. That raised every point up 1.2 and put the vertex at 0, 1.2. I mentioned that because that's a very important point. Okay. And it gives us some consistency with the graph. Okay, well, okay. Okay. Did you get 0.75? I'm going to guess 0.75. And I think one of you forgot that you had a minus sign here and added. Okay. So you made just a very minor error, but of course, missing a minus sign gives you a ridiculous answer because this thing's falling, it doesn't rise. Okay. So common sense tells you it rises. There is where having the picture and seeing that your result disagrees with the picture can be very beneficial because you know something is wrong. Either your picture is wrong or your algebra is wrong. Okay, turns out your algebra wasn't all that far wrong. You plugged all the numbers into the right place. You just lost track of a minus sign, something you see me do several times during this course. Okay, so don't feel badly about it, but be aware of it and be aware of how having a picture, even a rough picture of this graph, tells you that at t equals 0.3, this thing's going to be lower than it was. Okay, and of course, if you know what's going on, if you know that this is something that's falling to the floor, you know it's going to get lower too. And yeah, okay. Okay, now. If y equals 0, then we have 0 equals 1.2 minus 5t squared. Okay. And everybody was on track. I think everybody had that equation. And from what I saw, people were solving it correctly. Let's just make sure. Okay, you got 0 equals 1.2 minus 5t squared. So add 5t squared to both sides, you get 5t squared equals 1.2. Divide both sides by 5, and I'm doing all the steps because they can be done quickly, but I'm not going into a lot of explanation. Divide both sides by 5, you get t squared. 1.2 divided by 5 is 0.24. Is that correct? Did you get 0.24 if you divided 1.2 by 5? I think you would. So t is the square root of 0.24, which is approximately equal to 0.49. Okay. Now our estimate was 0.4. Our estimate is pretty close. Our estimate 0.8 is pretty darn close to 0.5. Okay. Now I was debating on this line whether that was 0.7 or 0.8. If I'd have said, well, I can't decide, so we'll call it 0.75, then I would have looked smart. Okay. But I'm not that smart. Okay. So t is 0.49. Now everybody understands? I think everybody got, how many of you got all of that? Did you get the t? Yeah, we'll use 4.9 instead of 5. So, you know, you might have been off by a hundredth or two. Okay, there were a couple little glitches in solving this. So let's be sure we understand how we get from t squared equals 0.24 to t equals the square root of 0.24. Okay, so we take the square root of both sides, okay? And we can do that. So the square root of t squared is t, and the square root of 0.24 is approximately 0.49. Okay. And of course, we wrote that much out here. Another thing that I saw when we got to this, somebody, and of course, everybody knows who, but that's okay. It's a good idea, but not quite executed correctly. Had 0 equals 1.2 minus 5t squared. Took the square root of 0 equals 1.2 minus 5 times the square root of t squared. This is not valid because you have to take the square root of both sides. So if you're going to take the square root at this point, you'd write the square root of 0 equals the square root of 1.2 minus 5t squared. And this is not wrong, but troublesome. Okay, it's not really progress. It doesn't help because you can't separate these two terms out here. So you want to isolate your t squared, but you want to be sure you do it using procedures. And adding t squared to both sides gets the t squared term on one side and everything else on the other. And then you can solve for t squared, take the square root of both sides, and get the solution. And this is also a quadratic equation, and you could even solve it that way. You know, you got negative 5t squared plus 1.2 equals 0. A is 5, B is 0, C is 1.2. Actually, A is negative 5. And you could solve it that way, but that would kind of be overkill since this could be solved more simply. Okay, I'm going to give you another bit of information. If I roll the thing at the right speed, pretty close to the speed I rolled it at, okay, x equals 0.2t. And you don't need to know what that means in terms of the physics. There's just an equation. Going to write y as a function of x. We want to write y as a function of x. How do we do that? Well, we know that y is 1.2 minus 5t squared. And now you know that x equals 0.2t. Can you use the method of substitution to eliminate t from the two equations and get a function of y with no t's in it, with x's instead of t's? Give you a second to see if you can get started on that. I'm not sure how much you've done substitution, although you had an assignment or two that involved substitution. But it was for linear equations. I don't know that we did it for equations of this nature. In your prerequisite courses, you should have seen this, but it's probably been a while and you might not remember. So just see if anybody remembers and sees what to do. It's real simple, but you got to see it first. Well, it seems that people aren't all that, don't remember substitution very much. Maybe just haven't seen very much of it. Maybe it's been a while. So the idea is fairly simple. We want to eliminate t, so we solve one of the equations for t and plug it into the other equation. So I gave you the hint. Solve the second equation for t. Okay. So we get and we could have solved the first equation for t, but the second equation gives us a simpler solution. So we have x equals 0.2t. Well, you might want to look at it with the variable you're trying to solve for on the left. So I'll just switch the two sides. Not necessary to do that. And many of you didn't, but it's okay. So either way, and we divide both sides by 0.2. And the 0.2's divide, and we end up with t equals x over 0.2. Now that's the same as t equals 5x, but we'll just do x over 0.2 for right now. Okay? I'm not worried about why that's 5x. Dividing by 0.2 is the same as multiplying by 5, but we don't really need that to finish the solution. Now, okay, well, do that. Finish this step for me. Plug in this expression for t and see what you get. Okay, so you have this. T is x over 0.2, so you're going to replace t with x over 0.2. And that's fairly straightforward now. So what do you get when you square x over 0.2? Okay, well, a little difficulty has come up here. And it's simply that people pretty much don't know how to square a fraction. Okay. Now, there are two ways to do this. So I'm just going to kind of do it over here in a little corner that I hope I won't need for something else. But x squared over 0.2 squared. Okay. And that would be x squared over 0.04. That's using the rules for exponents. Rule for exponents, and we went over it very explicitly in the MDE 60 class yesterday. So it's right there in the video, okay? And well worth trying to understand. And you know, other resources are obviously available to you. And I don't know why this thing is off the screen, but there it is. Okay. Now, why is x over 0.2 squared equal to x squared over 0.2 squared? One, that's one of your rules of exponents. The other is because x over 0.2 squared equals x over 0.2 multiplied by x over 0.2. Okay. Then how do you multiply fractions? You multiply the numerators and you multiply the denominators. So you can just write it out and use your rules for fractions. And you get the same thing, but in the process, we've proven that this works. Okay. And that's a general rule for exponents. All right. So now we know that y equals 1.2 minus 5 times x squared over 0.4. So that y equals 1.2 minus 5 over 0.04 x squared. Well, you divide 5.04, you get 125. Something's wrong with that. Kind of ridiculous. But let's pretend it's right. You know, that's going to reach 0 way too fast. X is a half, you get like 30. Well, X is not going to be a half. Okay. X is going to get up to maybe 0.08, and when you square that, okay, that's okay. So anyhow, there we have it. And notice that when I saw this, now it was my physics intuition that kicked in, and I didn't believe it. And I had to convince myself that that was reasonable. Okay. You always want to try to convince yourself that the result is reasonable. Now, in this case, you wouldn't be able to do that because you don't know what the physics is. Okay. But with other things, you know, always make sure that your solutions make some sort of sense. Difficult to do here. Okay. Okay, so anyhow, now we've got y equals, I'm going to write it as negative 125 x squared plus 1.2. Remembering what this means, when that ball is at the floor, well, we ask the question at the floor y equals 0. So what is x when y? Actually, the way I want to phrase it, I've given it away, but What is X when the ball hits the floor? Okay, now I gave you a big hint here. I said at the floor, Y is 0. Then when I stated this, I started to say, what is X when Y equals 0? And I said, no, I want you to think a little bit. What is X when the ball hits the floor? Okay. Well, I just told you at the floor, Y equals 0, and there's our equation. So I'm going to plug in 0 for Y. Don't have much room here, but I think I can probably solve in this much space. There's your equation. So we're going to let Y equal 0. And then we're going to subtract 1.2 from both sides. And we're going to end up with, just going to put 3 dots here. Under 25x squared equals 1.2. So x squared is 1.2 over 125. The square root of x squared equals the square root of 1.2 over 125. So the x equals the square root of 1.2 over 125. And that's approximately square root of 0.01. We get something close to x equals 0.1. Now, everything from here to here is very straightforward. Make sure you understand those steps. Take a look. We're nearly, well, not that near the end of the video. Probably 10 minutes from the end of the video. And look at how I solved that if you don't remember. And if you want me to explain it, well, there's the explanation. Of course, this step to here where I had the 3 dots, you just add 125x squared to both sides to get this. And everything else comes out in a manner very similar to other equations we've already solved today. There are other questions we could ask about this one. We could ask, what is x, which is how far the thing is going in this direction, horizontally, when y is 0.6. If y is 0.6, then we're halfway to the floor. So we can answer questions like that, but this should serve as enough of an introduction to allow you to think about problems of this nature. Okay. I want to shift gears a little bit. No, not shift gears. I want to do another example. So let's say we're manufacturing some object for sale. We'll call them widgets. That's a standard term in economics. Okay, so we're manufacturing widgets, and I do recommend that once you've completed the first semester of pre-calculus course, economics is had a really good elective. Okay, you learn quite a bit. I wish I knew more about economics, not a lot of mathematics, but as far as really understanding how an economy works, or at least how it's modeled, I don't have all the bits and pieces, haven't had time to do that. So the more you charge for something, the fewer you're going to sell, right? I mean, usually, okay. Are you more likely to buy something if it costs 50% more? Not if the cost is significant. I mean, if you're really hungry and you really need that candy bar and somebody's charging $1.50 instead of $1, if you're really hungry, you probably ought to eat something besides a candy bar. Yeah, times of desperation, it works. Okay. Probably not. If you're buying a $30,000 automobile and somebody wants to sell it for $45,000, you're probably not going to do that unless you got just money to throw away. Okay. So the more you sell it for, the fewer you're going to sell. So you've got this relationship, which we say is going to be a linear relationship. Okay. So it's like okay, if this is P and this is N, you have N equals whatever the y-intercept is here. So let's just say if you are giving them away, well, they take up space and people don't really need it. They're not going to want it. So there's a limit to how many people are going to take it. So not very realistic when you get down to giving it away, but we're going to pretend anyway. Okay, so let's just say that if you give it away, you're going to sell 10,000. Okay. Now, if you come out here, there's actually a point where this line hits the horizontal axis. Okay. And at this point, how many are you selling? Can you show me with your fingers? Where the graph hits the horizontal axis, how many do you sell? Somebody sells this way. Close, but less than that. Yep, 0. I mean, at this point, number in this axis is 0, right? Really want to be sure you understand that in any way that it comes up. Your intercepts occur when one of the quantities is 0. This intercept occurs when this quantity is 0, and this intercept occurs when this one is 0. Okay. So this occurs, let's say, if P equals $500. Okay. This candy bar is not worth $500. Okay, nobody's going to buy it for $500 unless they're starving on a desert island. If they are, don't have any money. Okay. Anyhow, there we got it. Okay, well, what's this equation then? Well, you have the two intercepts. The slope is negative 10,000 divided by 500, which is negative 20. You can use your slope-intercept form. Okay. Now, if the number sold at price P is this. How much money do we get from sales? Okay, well, to kind of frame the situation here, how much money do we get from sales? I said, okay, how much do you think one domino is worth? Okay, how much would this sell for? Somebody said 50 cents. Okay. Now, I pulled out a tub of dominoes. Okay, there might be 100 dominoes in that tub. As well, how much then would that tub sell for? If every domino sells for the same as this does, and people thought for a minute and said, well, you multiply what they sell for by how many there are, right? So that should be a pretty obvious idea, but we wanted to review it because it might be a good idea. Seemed like a good idea to review it, okay? We're getting instant answers. So anyhow, so what's the number sold? How many are sold here? Let me just write this down. Revenue is the price per item times the number sold. Okay. So what we're talking, we say, how much money do we get? Well, that's called revenue. How much money we get is revenue. So we're going to use R for revenue. Price per item is P. And that's our selling price, right? And we multiply that by the number sold. That's a very important model. N is the number sold. And of course, we have a formula for N in terms of P. We get this. And if we multiply this out, if we use the distributive law, we get 20p squared plus 10,000p. And that's a quadratic function. We can graph it. And we can answer questions about it. Now, there's a little more to this model. Not sure what to call this. We're going to say it's negative 20p squared plus 10,000 P minus 4,000. We're going to subtract that 4,000 from this, okay? Then I'm going to have to say this and be done with it because we're out of time. Almost out of time. Okay. Each item then costs $50 to manufacture. It costs 50 M, which equals 50 times negative 20 P plus 10,000, which equals negative 1,000 P squared. But then that's plus 500,000. And you got to subtract that from this. And you get a quadratic function that models your profit. So subtract this. I'm going to have to do too quickly, but 20 P squared this is going to be 980 P squared. This is 500,000 P. Minus 4,000. Is our profit. So now we can ask, how many do we have to sell to break even? Set our profit equal to 0. That's where we break even. Okay. We can ask what's our maximum profit. We just have to graph this function and figure out where the peak is. It'll give you some maximum profit. It'll also tell us how much we should be charging to maximize our profit. Okay. It's kind of unfortunate I use P for price because we're not going to, your book will use different letters, but we would use a capital P for profit. And this is a small P. Okay, so we don't want to confuse this P with profit. Should have anticipated that you read the models and stuff and see how it works. This is well explained. Okay. Read the material, work the problems because this is getting into true pre-calculus, and we've done a lot of work with quadratic functions. So you're well equipped to do that. Okay. Okay, very good.